All right, so up to this point, we've really looked at Matplotlib, and I wouldn't say quite extensively. It's a very huge library, but we've looked at a lot of useful um, functionality of Matplotlib. And in this video, what I'm going to do is show you Seaborn, which, I tend to use a lot. So, admittedly, most of the time when I'm doing analysis, my workflow, at least for visualization, looks like I'm using Seaborn to generate visualizations, and then I'm essentially plotting those Seaborn visualizations on Matplotlib axes, and I'm using Matplotlib's ability or functionality to kind of customize the various plots generated by Seaborn. So I wanted to show you kind of, some of the more common plots or some of the ones that I find most useful in Seaborn. Hopefully this, again, it's not going to be an extensive survey of everything you can do in Seaborn. It's a big library itself. But these are things that I find the most helpful. So let's just go out and look at Seaborn's website real quick, see if we can get a sense of what they're about. So here is the page for Seaborn, and you can see it is for statistical data visualization, and you can see right here there's kind of a gallery of plots. And actually, if you go to their gallery, right, so they've got some examples where they show you different plots that can be made, and I believe if we were to click on, say, any one of these, right, they've got some sample code that you can use to generate that. All right, so as you can see, those are very nice looking visualizations. They have a lot of different interesting configurations. A lot of times this is focused at statistical types of visualization, so a lot of things are based on distributions, a lot of ways to visualize distributions, and just a lot of very useful plots. So I want to show you a few of the ones again that I use most frequently, and kind of give you a sense of some of the parameters that are common to the various Seaborn plotting methods. So let's go ahead and get started. So I am going to import matplotlib .pyplot as plt, import pandas as pd, and then we will import Seaborn as SNS. All right, now I've got this data file called store sales forecasting.csv. So I have a playlist looking at pandas basics. This is one of the data sets that we used. Where can you get that data if you haven't looked at that playlist? Well, you can go to Kaggle. And then when you're searching, you can say, well, let's go to store sales forecasting. That'll be the search term that you should use. You can filter that to data sets. And then you've got this store sales forecasting data set, Tenaya Tipre. And if I click that, you can see there's that CSV file. So you can log in, download that. And of course, it'll give it back to you as like a zip archive, I believe. And you can, extract that file and you can have it. So I've done that. I've got the CSV file right here in the same directory as this untitled notebook that I'm working from. And we'll just go ahead and we will read that data. So in our pandas basics, we saw that, okay, we can import that data set, so do a pd read CSV, but there was an encoding issue, so it could not load the data when the default, using the default encoding value, which is UTF-8. So apparently there's some characters in there that are not compatible with UTF-8. So we had to use a Latin 1 encoding, and this should get us our data. And let's go ahead and look at the first 2 rows. All right, so in this case, this store sales forecasting, so we've got entries that are corresponding to, various orders, and you might have multiple rows corresponding to the same order. So in this case, these first 2 that are being shown here, the order ID is exactly the same, but you do have products coming from different subcategories. So I think that, it's like an order subcategory, or maybe even an order product level of differentiation in each row. Nonetheless, that's not going to be, too concerning for us. So let's just first look at Matplotlib. So let's just say, okay, well, what if we wanted to get an idea of, the average profit? All right, so if we were to just look at what's the average profit on an order by subcategory or per row, right? So again, just doing some simple analysis. The goal of this is to show, the plotting the utilities available in Seaborn, not so much to do very in-depth analysis. So we've got subcategory. Each one of these rows might have different subcategories, and we're just looking at, well, for each one of these rows here, there's a profit recorded. So what does that mean, profit? And then break that out by subcategory. All right, so we can do a dot group by, and we could take that subcategory column, do an ag, and then we'll say this is going to be our mean profit. And we're going to take that profit column, and we're going to take the mean of that. All right, so this gives us a pandas data frame. We've got the subcategories in the index and a single column called mean profit. So this is a pandas data frame, so we can call a dot plot off of that, and we could say, well, let's make this a bar plot, since we have essentially discrete things in the index, which will eventually be, used to populate the horizontal or x-axis in our plot. Let's go ahead and say edge color equals K, and then I think it'll put a legend in there, but we don't want the legend. All right, so this is what we get. It's a little bit of an interesting plot because, if you some of the categories, some of the subcategories, in particular bookcases and tables, the mean profit is negative. So you kind of look like you have these bars suspended kind of like just in random places, but there's actually that zero line. So let's use matplotlib to make this look a little bit better. So I'm going to say fig ax equals plt dot subplots. Whoops. 1, 1. Big size equals, let's say 5 by 3 for now. See how big that is. I'm going to tell pandas when you do that plot, put it on that AX object. And then I'll do a plt.show. All right. And we could do a little bit of customization. So let's take off those right and top spines. So set visible, false. And then what I want to do is, because of this weird effect of it looking like these bars are kind of floating because some of them are negative, I'm going to draw a horizontal line here. So to do that, I'm going to do an ax.axh line. So it's axh line. And I want to put that at y value 0 in this case. Right, so it puts me a nice line right there. I can change the color of that line to be black. And then we could do, let's just do one other thing, and then we'll kind of call it a day using the pandas plot. So let's just say this is going to be our mean profit. And that should be Y label. There we go. All right, so this is our mean profit as computed by pandas group by across all of those items. Now, one thing that we lose here, right? So if we look at this plot, and again, this looks visually, this is fine, right? There's a good bit of code, right? So in this case, we had to do our grouping and aggregation using pandas. We did the plotting there. And one thing that we kind of lose is we're just looking at the mean, right? So if I were to ask you, well, is there a statistically significant difference in mean profit by these categories? You might think that you could answer that, right? Because you're looking and say, well, okay, well, bookcases is negative, tables is negative, and furnishings and chairs is positive. But you really can't say anything about the statistical significance because you're just looking at a point estimate, right? You've computed the mean. Right, so you have no idea how much variability there is in that profit, right? So if we were to, look at this, if we consider this, maybe this is just a sample of orders, right? We really can't say much about this because there could just be one really low value in bookcases that's pulling that mean down, but the majority of them are kind of, close to 0. And, we really can't tell, anything about the variance associated with this. And this is really where, I would kind of start turning to matplotlib, or not matplotlib, but Seaborn to start generating some statistical graphs to kind of help me, start to get a sense of that variability. Right. So again, let's say, and what if we weren't talking about statistically significant differences between them, but maybe I was saying, well, is the mean profit, can we say, that with statistical confidence that the mean profit is not equal to 0 on any order. So, we can kind of, we need to look at the variability there to start to be able to assess that. All right, so let's look at Seaborn. So we've got this data, all right, and there we were just looking at subcategory and this profit amount. So let's see if we can figure out, well, what's the distribution? How is the profit for a particular product in an order? How is that distributed? All right. Well, we used a bar plot before, and we've got Seaborn imported as SNS. Well, if I do a SNS dot and hit tab, you can see that there's a lot of different methods and functions, modules, not so much attributes here. I guess we do probably have some attributes in here, but most of it's methods or functions and modules. But a lot of these correspond to plots, right? So we do have a bar plot method. And let's look at some of the arguments. All right, so this is going to be one thing that's pretty common with Seaborn. So you're going to have the option to provide a data argument, right? So provide something in data. Let's look at what that should be. So it can be a data frame, a series, a dict, array, a list of arrays. So this is your plotting data set, right? So one thing to note is it says data frame and series. So Seaborn out of the box is, designed to work very well with pandas and actually polars as well. So since polars has emerged onto the scene and been a very strong contender in that kind of data frame or tabular data analysis aspect for Python, they have updated Seaborn to include polars data frames. Right? And it says, okay, well, if you give me data, then the X and Y, so if we look here, so this is, if we look at these arguments for X, Y, and Q, this is names of variables in data, or you have to give it vector data. All right, so let's put all of this together. All right, so we imported or read our data into a variable named data, so I'm going to specify that as the data argument. All right, and then what I can do is I can give it some X. What do I want to be on the horizontal axis? Well, we had said subcategory. So now that I've given it that data frame, I can just say, well, okay, well, I want on the X, I want to actually use the values from that column subcategory. And then for Y, so what I want on the vertical axis, let's just use that profit from each one of those lines. All right. All right, so let's take a look at this, right? So first off, let's go ahead, another argument before we do that. It should, let's look down. Yeah, it takes an AX object as well. All right, so let's go ahead and I'm going to copy that big AX from above. And then I'm going to get all the AX spines and whatnot from above. And then I'm going to pass that axis to my Seaborn plot. All right, so this is basically the same plot that we had before. And you might say, well, it looks very different. Well, the one thing to note is that the order of the subcategories is different. So Pandas is doing a sort there because that come out of a group by. Notice we didn't have to do a group by here. We just gave it the data. And so when it's figuring out those subcategories, it's just doing that in the order that it sees them. So if I were to actually take my data and sort the values, and sort values, and let's say by subcategory, right, that's going to sort those subcategories, and it should be in the same order that we saw it in the Pandas group by, because it does a sort when it does the grouping. So now these look exactly the same as far as what they're plotting. But one thing that you should notice is that we're getting additional information here. So notice these black lines, all right? So in addition to the bar plots, and let's go ahead and do some edge color to make it look as closely as we can, right? All right, so we've got the mean profit, and then we've got the subcategory. But now, in addition to just the bar plots, we actually have these black lines. And what that's doing is that's giving you a confidence interval for the mean profit for each one of those subcategories. All right, so it's saying, okay, well, if I look across all the entries for bookcases, on average, the profit is like -18, right? But if we think about it from a statistical sense in the distribution, so there's definitely going to be some entries in that data where the profit for a bookcase is positive and somewhere it's negative, right? So it's saying, well, if I look at how that's distributed, I can be 95% sure that the mean profit for a bookcase is somewhere around like -40 or up to positive, maybe like 5 here, right? So notice that black interval right there, it includes 0. Right, so we can't say with statistical confidence, at least at a 95% significance level, because that's by default what it's going to do. So you see you've got this error bar argument, and it's giving you a confidence interval with a 95% confidence limit. So now it's saying, well, I can't say with, statistical confidence at a 95% level that mean profit for bookcases is different from 0. So this gives us a little bit of a different insight, right? So, and if we actually look for bookcases and tables, right, those intervals, it's hard to kind of see because there's a little bit of distance, but those intervals might overlap one another. Right, so we can't really say that, we can say with, statistical confidence at a 95% level that there's any difference in that profit between tables and bookcases. So this is some of that additional information that we can start to glean using these statistical visualizations. All right, another thing again that's nice, how's it doing this? Well, remember when we did this with pandas, right, we had to do the processing ourselves. So we took the data, we did a group by, and we got the mean profit. So what we were actually plotting when we were using this pandas plot, right, we're just plotting those point estimates for the mean, right, because we've done a group by and an aggregation, so we've got one value for each one of our subcategories. Notice that is not what I'm doing when I'm looking at Seaborn. I'm giving it all of the data. So it's actually using each one of the data points to come up with that distributional estimate there, so to estimate that uncertainty. All right, so I won't say that this is always the case that you will see with Seaborn where you'll just give it all of the data. There might be some cases where you still use group by, but in Seaborn you can just give it the data, and a lot of these plots will come back and allow you to kind of look and incorporate for that variance. All right. I'm going to just copy this down below, because another nice thing that you can do with Seaborn is you can add a hue parameter. So a lot of times we're not just interested in how is one thing varying. We might be interested in maybe two things, right? So for example, if we're looking at data.head here, all right, so notice we've got this region. So maybe we want to look at region and subcategory. So, well, is the profitability, does it change not only by subcategory, but is there an interaction between region and subcategory? All right. So in this case, I'm actually going to change from that X being subcategory. I'm going to just cut that out. And I'm going to say, let's look at it by region. So is there a profitability difference by region? We can generate that plot. And we can see that there does seem to be, right? Even though, again, we're getting these error bars that are, quite wide. And that might limit us from being able to say, yeah, there's a statistically significant difference. All right, but I can add this other parameter called hue. And let's make that the subcategory. All right, so now what it will do is it's looking, okay, well, our region is varying along that horizontal axis, so we can see the south, central, east, and west. And then within each, we've got additional colored bars that are looking within the subcategories. So I'm just going to use Matplotlib real quick to move this legend. I think I can just do a ax.legend and then do a bbox to anchor. And we'll set that at 1, 1. I think that should be fine to get that moved out to the side. So now we can start to get, some additional insight. So in particular, right, well, if we look across, the subcategories, like bookcases, chairs, furnishing, and tables. Seems like chairs are pretty much always, the average profit is always positive, right? So those bars that correspond to chairs, they're always above that horizontal line that's at 0. And moreover, the confidence intervals are also above 0. They do not include 0. So chairs seem to be profitable everywhere. That same thing can't really be said for other categories, in particular tables, right? So if we look for the South region, Central region, and East region, the tables is the mean value is less than 0. And in the case of Central and East, the confidence intervals are also strictly less than 0. So the interval does not include 0. And then we can start to, even get additional insight, like the Central region tends to be, the least profitable on average for the majority of subcategories, right? So everything except for chairs. So something is different about the Central region than any of the other regions. And again, as far as profitability, tables tend to be our weakest spots, whereas chairs tend to be our best spots. All right, so this is giving us kind of the confidence interval look. You can do that right out of the right off with bar plots. I think that's really a nice touch. I like to use those a lot, especially with some type of a hue parameter. Just to show you, you can also do this if you wanted to look. So these bar plots are using a 95% confidence interval, so it's estimating the variance in the mean, right? So it's like, okay, well, I can be, again, the interpretation of those black lines is this is essentially an interval where we can be 95% confidence that the mean value lies within that interval. That's not necessarily showing you the range of values that you see in your data. Right? It's just saying, well, based on the data that you have and the variance in that data, I'm 95% confident that the true mean lies in this region. All right, and again, assuming that your data is a sample, which pretty much all the time it is. All right, so I just copied that down. In addition to a bar plot, let's just say, right, another very common plot that people want to use is a box plot. So box plot does not have an edge color. So that's one thing to note is, again, these different types of plots might have different arguments. So in that case, I tried to just copy it and change it right from a bar plot, but it didn't have an edge color argument, so I had to rerun that. And now we can generate that same plot, which this is a little bit too busy for me personally. But now we're using box plots. So if you don't remember how box plots are computed, you can just say box plot and then probably Wikipedia, right? You can go here and see how to compute a box plot. But the nice thing is you don't really have to. If all you're trying to do is visualize this, right, this will get the job done, right? I'm going to take that hue out. All right. And then I'm going to take the legend off, because apparently when I take the hue parameter away, that's used to populate the legend. So it doesn't give me an error, but it's telling me, hey, you talked about a legend, but I don't have anything to put in the legend. All right, so what this will do is it's showing you the extremes of your values. So when I'm using a box plot here, it's basically showing you, the median, the 75th, 25th percentile, and then it's using these circles to identify values that fall out of kind of, that normal threshold that is used in a box plot. Again, go check that reference at Wikipedia. But you can see, like in the South, right, there was like one entry right here in that bottom left on the South that was close to, a negative $1,900 roughly in as far as profitability. So it cost them a lot of money. So probably somebody was leveraging a discount. They saw a discount on something and they bought a lot of it, right? So that could definitely be skewing those observations that we're seeing for the South region. And then you also see it for the East region, right? Whereas if you look at the Central region, it's kind of much more evenly balanced. Across, we don't have as much of an extreme outlier to the negative and positive side. So that could be influencing that. So again, we can use these to kind of better understand our data. What if we just wanted to look at the profit overall, right? Well, I can take out the X parameter right? And this is just that distribution of profit as a box plot. All right, now again, this one's really busy. You've got a lot of outliers. Let's see what other arguments that we have here. Let's see, so you can tell it, you know, the whiskers. Let's look at some of those parameters. All right, so parameter that controls the whisker length. I was wondering if there was something where it could say, oh, we don't even want to see the outliers, but it doesn't appear. All right, so that's a box plot. Another plot that I like to use a lot, and we would just kind of, I'm going to copy down this code right here. Let's copy it down from our original bar plot. Another plot that I like to use a lot is a point plot. All right, so again, here's our bar plot, right? And this is fine, but sometimes I don't necessarily want the visual clutter of the bars themselves. I just really am interested in looking at those confidence intervals. And you can do that with a point plot. All right, so a point plot will not have an edge color. All right. So let's just take a look at this real quick. All right, so what a point plot is actually going to do is it's just generating those confidence intervals. In this case, we've got a hue parameter, so for all of our subcategories and by our different regions. So for now, let's just take our subcategories out. So I'm going to take that hue parameter off and take the legend off. All right, so these are confidence intervals that we can use to compare the profit, the mean profit, or the confidence intervals for the mean profit across different regions. All right, and again, if any confidence intervals are overlapping, we really can't say that there's any statistically significant difference, even though the means might be, you know, if we were to just do a bar plot, the point estimates will look different. All right, so one thing that I like to do with point plots is they, by default, join them together with a line. But again, these are categorical. You know, in this case, we're plotting across regions, so those are discrete items on our horizontal axis. So I like to set that join parameter to false, right? And it's actually telling us right here in Seaborn in a recent version, okay, so this parameter is going to be deprecated, right? So we're seeing what this is called as a deprecation warning. So it's going to be removed in a future version, and they're saying, hey, you can remove this line with this line style equals none. All right, so this is a good example because these libraries in Python are always evolving. So it used to be join. We can see that that still works, but they're giving me a warning, hey, that we're not going to use this going forward. So instead of join equals false, I can say line style equals none, and we get that confidence interval plot. Now, again, we can look at this and we can answer a lot of questions so we can say, well, can we say that the profit is different from 0? Right, so anytime the intervals are overlapping 0, we can't say that really those things, you know, we can't say with statistical confidence that the mean profit on a cell for a particular order is profitable. So for the central and east, and then if we'd have to really look closely at the south region. All right, very good. Let's look at now a couple of other plots. So let's look at our data. Let's say that we wanted to, you know, get a sense of, let me just get the head too. All right. So as you recall, each one of these line items is essentially, you know, some type of an order ID, and then we've got, you know, a subcategory here, and then we've got a quantity. So each one of these, and it could be, of course, haven't checked all of the data, but it could be, I guess, that we have different, you know, it might even be that we have the same order has multiple rows for the same subcategory, but they're different products. All right, so let's just say, well, okay, for a particular subcategory, when we order a product, what is the distribution of the quantity? So for all of the line items in here that correspond to bookcases, you know, how many do we tend to order, right? So I might say that, well, I would imagine bookcases or tables is going to be, you know, that distribution is going to tend to be smaller or be more to the left than one for chairs. We might order more chairs, but let's see. All right. So a good plot to do this, and I'm just going to copy what we had here because I'm just using that matplotlib infrastructure. All right, I'm going to take off that Y label real quick. All right, so if we wanted to know the distribution of this column, okay, with respect to this subcategory, the plot that we would want to use, we could use a hist plot. All right. Okay. So again, it takes data, it takes X's, and it takes Y's. All right. You can give it a hue as well. So let's think about this. Well, we want to know what is the thing that we want to essentially show on the X. Okay. And actually what we want to be showing is we want to show the quantity, I believe. So with a histogram, we're going to essentially take this column here and we're going to break it into some bins, and we're going to see, count the number of times that we have data that falls into each one of those bins. Again, if you're not familiar with how a histogram works, right, so we could just go histogram, Wikipedia, and there we go. Right, so if we have data, what it does is it essentially takes a column of interest. So if we have 500 items worth of data, and there's some numeric column that ranges from like -3.5 to +3.5, we essentially take all of those 500 entries, we construct bins that equally separate that range from the min to the max, and then we have a count of how many times items fall within each one of those bins, and we can use that to visualize the distribution. So like in this example they're showing, it tends to be most items are around that 0 category. All right, but we don't have to figure all of that out. Seaborn will do that for us. So I'm going to say, well, the thing I want you to bin is the quantity. Let's just look at that first. So this is basically going to say, all right, so for all the entries in this quantity column, what does that distribution look like? All right, so we can see that, okay, across all of these records, it tends to be that most of the time it's either 2 or 3 items that are, or 2 or 3 of those products that are being ordered. And then we have it as high as maybe 14 all the way down to 1. All right, so this is our histogram. Right, we could give it a hue, right, and we could say, well, let's make that by subcategory. All right, now in this case, what it's doing is it's kind of putting them right above one another, right? So it gets a little bit hard to see exactly what's going on. So you've got your bookcases, chairs, furnishings, and tables. So a little bit, so again, somewhat difficult to see. Let's see if there's some arguments that would maybe help us do this. Let's see. So elements, so multiple. So let's look at this multiple argument. All right, so if it is the approach to resolving multiple elements when we have subsets, so I think by default it is set to layer. Right, so if we look at these multiple, it's layer. So I think another option is maybe dodge, right? Let's see, where's multiple? Probably going right by it. Let's see. Yeah, multiple, we could dodge them, right? So we could say, well, multiple. All right, so you can kind of see. Now again, this is maybe not the the best way to visualize this data, but you can see that you can actually compare, well, what's the the number that are being put into each one of these bins by subcategory. Right? So personally, if I were using a histogram plot, I would probably not do that with a hue. Right? I just want to kind of understand what that distribution looks like. And by default, it gives you a count. If you wanted to convert that into like a probability or a relative frequency, and it has a stat argument, by default, that's set equal to count, but you can make that a probability. All right, so we can say, well, let's make the stat equal to probability. All right, so now you can kind of see, well, it's, greater than 20%, likelihood that we'll order two of a particular item, or, three of a particular item. So you can start to think about that as a distribution. All right, so you can get a sense of a distribution that way. Or another plot that I do use frequently, instead of a histogram plot, there is a plot called a KDE plot. I'm going to take that stat argument out because I don't think that is defined. And let's see what it's asking for. So we have data, we have X and Y. Let's look at this real quick. So a kernel density is visualizing the distribution of objects in a data set. KDE. So one thing that we might be running into an issue here. So I'm using this on that quantity field, and notice that it's not showing me anything. And I think the reason is, so a KDE, that stands for a kernel density estimate. So if you look here in the definition, so a kernel density estimate represents the data using a continuous probability density curve in one or more dimensions. Well, we're using this with discrete data. So the cell quantity can either be 1 or 2 or 3 or 4. It can't be like 2.5. So let's give it another column. Let's look at the head. And let's do this. Let's do the distribution of sales. All right. So instead of applying the quantity, we'll do the sales. And we are still getting very, very low. Let me just take that line style. It might be that line style argument. There we go. So it was line style. So again, when they changed some of these parameters, so maybe we would have gotten a kernel density estimate if we would have used our quantity. We can actually check that in a minute. But it probably makes more sense for sales because that could be a continuous, but this is going to give us a different estimate. So what it does is it takes the data. Let's just look at the difference here. So what if I were to do a hist plot for sales? Let me take that line style out because that gave us some problems. All right, so this is what your histogram looks like for sales. So this is your hist plot. So we have a lot of very low sales, but then we've got this long tail. And this KDE will essentially create a smoothed estimate of that. All right. The one reason I might say that I would use this is let's just kind of look. Remember, if we're looking at our hist plot, remember what will happen when we put that hue in there. All right, so if I put the hue like region, all right, so we're looking at this histogram for sales by region. It's kind of hard. It puts everything on top of one another, right? So that gets a little bit challenging. So, don't necessarily prefer this. If I'm doing just one thing without a hue, wanting to just look at that distribution, a hist plot does very well. But with a KDE plot, right, we can actually fill that. So if I were to look at that fill parameter, we can say it's a Boolean or, none. So I can say, well, fill equals true. All right, so it fills that in. And now if I give it a hue parameter, let's say region. All right, a little bit, to me, this is at least a little bit easier to see that distribution. So we can see that they're largely overlapping, but we can at least see, well, there's the south region, so that distribution doesn't peak as much. And then we can kind of look at those tails as well. So we can say those distributions of sales are not very different. Let's just make sure that, so it is doing that layering in that KDE. So it does have that multiple, but it's just layering them one on top of the other. All right, so you can kind of use this to kind of see those differences. All right, one thing that I will say that is kind of a problem you need to recognize with the KDE, like let's go back and take that hue out of our KDE plot. So here's our histogram of sales, and then here's our KDE plot. And you can see that they look somewhat similar, but there is a big difference in that our sales starts at 0. So it peaks right around 0, and then it really kind of tapers off and tails out going down to the right, or higher sales values. This KDE is essentially, the way to think about it is imagine that you were laying a blanket. Imagine that you had some object that took on the form of this histogram and you laid a blanket over this. Well, the blanket might not hug it exactly. It might kind of taper off in certain regions. And because of that, what it actually looks like, and I'll do an AX dot AXV line. So that's 0 cells. So you can see when it lays that blanket, and because of just kind of that flowing right there, that smoothing effect, you get some cells that are negative, right? And that's not true, right? I mean, that's not actually in the data, but remember this KDE, it is an estimation. And again, right, if you want a little bit more details on kernel density estimates, good old Wikipedia. So you can look at kernel density estimation here to kind of get a little bit of an understanding of what it's doing, how it's doing that smoothing. So here's a histogram, and this is what the KDE would look like. All right, so his plots are useful. Let's look at another plot that's going to be very, very common. All right, so we've got our data, head, 2. All right, so we've got this discount column, and then we've got profit. So what if we wanted to figure out, is there some type of a relationship between the amount of discount that people are using and the profit that we receive from that? We would expect that to be true. Well, a lot of times if we're looking at those 2D type of relationships, we can use a scatter plot. All right, I'm going to take off that sort values here. All right, so for a scatter plot, you give it data, you give it an X and a Y. So I'm going to say, well, I want to look at, profit as a function of discount. So profit versus discount. So profit on the Y-axis, discount on the X or horizontal axis. All right, let me take off my vertical and horizontal lines. So this is a Seaborn scatter plot. Again, we're just giving it the data. We give it those columns. And what it does is it creates a scatter plot. So what we can actually see here is that as we're going left to right, so apparently they only give discounts in like, tenths of, or represent as a proportion with a single decimal point, so 0.0 or 0.1. We do apparently have a 0.15, so there are some intermediate values. But what you can see is as we go from left to right, so as the discount is increasing, that profit tends to be decreasing, as we expect, right? We give more discount, we're essentially taking away from our profitability. All right, so this can be used to show that relationship. One thing you've got to be careful about when you're using scatter plots is a lot of times, like in this case, you might have a lot of points that are overlapping one another, right? So what I like to do a lot of times is give it some edge color. And then there's a parameter called alpha, which you can use to affect transparency. So this 0.4 is going to set, where, it's going to have, as alpha gets lower, the objects get more transparent. All right, so now you can start to kind of see, I've got that edge color, you can see those regions of density. And if I even went even further to the extreme on alpha, you can really start to see where those points of density come in. As opposed to if we did alpha of 1, right, you kind of get some circles completely overlap others. But when you get alpha down towards very, very small values, right, you can actually see, there's kind of these really transparent pieces, but then the regions of density really start to show up. All right. So that's a scatter plot. Another one that is actually, so if you are in a situation like this, you're trying to figure out if there is a relationship. Another one that's really kind of helpful for a kind of a quick and simple analysis. Instead of a scatter plot, you can do a reg plot. And what it will do is it's going to do a simple linear regression. So if I'm trying to figure out, okay, well, is profit changing as a function of discount? All right, now we run this. Oh, it doesn't have an edge color argument. So let's take that out. Let's take our alpha out as well. So what it's actually doing is it's showing that scatter plot, and then it's doing a simple linear regression line. So you can see that that regression line is sloping downwards. So there tends to be a negative relationship. So as discount increases, our profit, discount increases, our profit decreases. Let's look at some of the arguments that we have here. So interestingly, if you remember when I did this edge color, right? So that doesn't work. But, interestingly, when we were doing our scatter plot here, we used edge color and alpha to kind of change those. Well, we've kind of got a scatter plot going here, so why does it work? Why doesn't it work? And you can see this in the arguments. And this is just one thing to let you know of. Again, I want to kind of show you how to maybe interpret some of this documentation. Notice when you do the reg plot, you've got this scatter keywords. And if we go down and find that argument, so scatter or line keywords, so these can be dictionaries, and these are additional keyword arguments passed to plt.scatter or plt.plot. So if I put plt scatter here, well, that takes me to some matplotlib documentation. So that does tell you that Seaborn is actually built on top of and interfacing with matplotlib. So when you're doing a scatter plot, you're probably calling this matplotlib scatter plot function, and Seaborn's just doing some additional modifications on top to show those statistical visualizations. All right, but here's PLT scatter, and if you look, let's just see, okay, so we've got edge colors. Let's look at keyword arguments here. Let's see, so keyword arguments go to this collection, right? And yeah, we kind of go way down the wormhole right here. Maybe there is an edge color. Yeah, so there's actually our edge color argument. It goes all the way back to here, right? So that's where we get it. But where I was going with this was when we were looking at this reg plot, well, it had this scatter keywords thing. Well, we know that it's using a scatter plot underneath. So if I want to scatter, it's called scatter keywords, KWs, and I can pass it a dictionary. I can say edge color, K, and then let's say alpha is 0.1. All right, so we can use those arguments, right? And the key thing is that when Seaborn is making this regression plot, it's actually combining two plots. It's combining a scatter plot with a line plot, where the line plot is actually plotting the regression line. All right, so one other plot that I tend to use a good bit that I do want to kind of show you is a heat map. All right, so let's just say that we are wanting to figure out, okay, well, who tends to use different ship modes, right? So let's look back at data. Let's look at the first two rows. So for each one of these entries, in addition to having information about, the subcategory and all the sales, we have the region. We also have the ship mode. Well, let's see if we, maybe we're interested in figuring out, well, do certain regions utilize different ship modes in different proportions? All right, this is going to be the one case where we will want to use pandas, right? Because we want to get this one down to point estimates. So what I'm going to do is I'm going to say, well, let's group by ship mode and region. Region needs to have a capital R. And then I'm going to do a .ag, and I'm going to say this is going to be the unique orders. So I'm just going to look at how many orders utilize different ship modes. So I'm going to say orders, orders. And I'll take the order ID column and get the N unique from that. Awesome. And then what I'm going to do is I'm going to reset the index to get those, because it gave me back a data frame with ship mode and region as a multi-index. So I'm going to reset that to bring it back in as columns. And then I will do a .pivot where I've got maybe, I don't know, let's do region as the index, and then as the columns, let's do ship mode. And then as our values, let's do whatever's in that orders column. All right, so this looks fine. And let's say that what I want to do is I want to essentially convert each one for the region into a proportion, like this 59. Well, it could be, I want to actually look at this as what is 59 as a percent or a proportion of all the orders that come from the central region. So I'm going to represent there the number of orders they ship with each class as a proportion of the total. So I'm going to say this is going to be orders by mode and region. All right. And what I have to do is I have to use the divide method of a pandas data frame. So what I want to do is I want to divide. And what I'm going to do is I'm going to sum. I want to take the sum across each row. So that's going to give me the sum for a region. So that's going to be the sum across axis 1. And then I'm going to perform that division, applying it to each entry along axis 0. All right. So in this case, it's like 61% of the central region orders are shipped with standard class. Just to make sure that these proportions are what I expect them to be, I can sum that across axis equals 1, and they should all sum up to 1. So we've got 100% represented for each. All right, so I'm going to use that to overwrite orders by mode and region. All right, so this is what our data looks like. So if you've ever got some type of a comparison like this, where it's kind of like a two-way, almost like, comparison table, what we can do then is I can say, well, give me back a figure. plt.subplots. Let's say, for now, let's just do 4 by 4. Let's see if we need to change that. And then what we want to use is a heat map. So if you give it data like that, what it will do is it's going to create some type of a gridded plot where you've got individual entries in cells based on your data. All right. So I can already see that, let's make it a little bit wider. Let's do 5 by 3. All right, so the heat or the coloring of each one of these cells is going to be based on those values that were in your data. And this color bar over here to the right is essentially allowing you to translate that to values, right? So if we think about it, so 0.6 tends to be towards that lighter color. So it seems the majority of things are shipped with standard class. And then, maybe the next one would be something like second, and then first class, and then same day. What I like to do with these heat maps, again, this might not be the most interesting heat map to display. Let's do a little bit of a different one then. Let's say instead of orders by mode and region, let's say we want to go by ship mode or not ship mode, let's go by region, and let's do subcategory. Category. Spell that correctly. All right, and I'm going to say this is going to be orders by subcategory and region. Do the same thing there. So columns are going to be subcategory. I know I'm changing this right here on the fly, seeing if we can get something that's a little bit more interesting. So everywhere I have mode and region, I'm changing that to subcategory. Let's see what this looks like. All right, so essentially what we should be getting here is basically this is saying, well, okay, well, what's the proportion of orders that, contain furnishings or chairs? And we're not looking at the quantities here. We're just saying, does it contain, a particular, any product that's within these categories, right? Let me just double check real quick to make sure that if I do a sum across axis 1, yep, 100%. All right, so one thing, there might actually be some interesting insights here, right? So we can see like the furnishings in the South region tends to be higher than other categories. But to me, it's always a little bit hard looking at this because I got to kind of visually map to this color scale over here. And well, is this cell, 0.15 or is it closer to 0.2? It gets hard. So what I like to do is take the C bar away. All right. I like personally to change the the C map to cool warm. All right. So just to show you, if you were to look up, so I'm going to say Seaborn color maps. All right. You can go to the documentation, kind of scroll down, right? And they show you, they've got a lot of different color palettes here that you can pick. I'm going to try to find the one that I was just looking at. Let's see. So that's light B. Yeah, so here's the one I'm using. This is a diverging palette. It's called Cool Warm, right? So it'll go from low values being a blue all the way up to a darker red for the highest values. But you can go get that information on their documentation page. All right, so for those changes, we've got something like this. And then, and this is, if I'm doing a heat map, what I tend to want to be careful to make sure that I don't have too many categories. Otherwise, it's really, really hard to look at. So in this case, I've got 4 subcategories, 4 regions, so it's not too many, so it's not too busy. And in those cases, I can say, hey, annotate that. It has an ANNOT argument. You can set that to true. It will put the values in there. So now you can see the coloring and you can also see exactly what value that's corresponding to. And it's visually giving you an idea of where the highs and the lows are. And you can actually format that. So right now, this is correct. We had it as proportions, but if we look at the arguments, it's got this format. So .2g, all right. So we can provide a format string. So if I wanted to do it as a floating point number with 3 decimal places, I could do, a .3f. That gives me 3 decimal places. If I wanted to do it as a percent with 1, I could do like a 0.1%, and it's going to multiply all of those values by 100. All right, so again, we can see with in the South region, they tend to be ordering, at least based on these point estimates, right? They're ordering, more furnishings and tend to be ordering less bookcases, right? So just little subtle things like that. All right, so that was kind of a whirlwind tour of, plots that I like to use in Seaborn. A lot of these are different than things that are available in Matplotlib, or you could do them with Matplotlib clearly because Seaborn is using Matplotlib under the hood, but it would be tedious. So Seaborn can make life a lot easier. One thing to note, I think the documentation of Seaborn is pretty good. The arguments are pretty self-explanatory. The one thing that's really kind of interesting and consistent among all is this ability to do, interaction. So we can use that hue parameter to plot, differences among multiple things. And I think that's a really nice touch. So, yep, play with Seaborn. And again, we're using this with Matplotlib. So we've got pandas data. We're using Seaborn to come up with a visualization that we're putting on a Matplotlib axis. So these 3 things really work together well. And polars also works well with Seaborn nowadays. So yeah, it's a great library. I think it can make life a lot easier when you're trying to construct meaningful, informative visualizations. And that will conclude this video with this fire hose whirlwind tour of Seaborn.